Hey guys, welcome to my first video, I guess. Yeah. So today, what we are gonna do is some AI fun. Okay, so I've been going through this really great course called Fastai. It's a great course to start if you want to start learning deep learning, and this is the best thing is like it's free. It's one of the top courses out there, and you can just with a laptop and internet you can start learning deep learning. You don't need big GPUs or money to buy servers and all that. So let me show you how. So this is the website course.fast.ai, and there are multiple um, ways to learn this. One of the ways is Collab, Gradient, and SageMaker. So I'm using Gradient for this tutorial. So it's easy, it's free, and it's very easy to set up. You can go through this. So I'll show you. I have my notebook set up here. So okay, so this is the base directory when you start with the FastAI course on Gradient. So basically, just an introduction of the course. It's like a great course, and it's divided into 20 chapters. Each chapters, each chapter has its own Jupyter notebook that you can go and learn on. So I'm gonna base this video on the second chapter, which is about deploying a model into prediction, and it's like very easy. In just a few lines, you can train state of the art machine learning model and image classifier basically. So basically this chapter talks about how we can build a image classifier around bears. So basically three type of bears, that is uh, teddy, grizzly, and black, and we can classify that. So without much further to do, we're going to use the example here and train our own classifier. I have called that as BikeNet. So I was just thinking of something that we can teach a computer to learn and identify. So I think bikes are a good part. So I really found this cool website which talks about the different types of motorcycles. So we're gonna choose 3 to 5 types. Let me sip my black coffee. Yeah. So what we're gonna do today is, you know, take 3 to 5 types of bikes, download some images, and train a model on that. And finally, our model will be able to, classify which type of bike it is. So it will be pretty fun. Okay, let's start. All right. So uh, let's see. Let's take 4 types. So I like dirt bikes, scooters, uh, race bikes, and cruisers. Yeah, cruiser bikes. Okay. Or let's see. Okay. Uh, sport bike, sport touring, moped, the bike, uh, touring, cruiser. Okay. Okay. So let's define the type of bikes. Okay. Bike classifier, bike types. So it's gonna be sport bike, sport, uh, dirt, scooter, and we're gonna use cruiser. Yeah, cruiser, cruiser, cruiser. Cool. Okay. So basically, when we finish, our model will be able to identify between these types of different bikes. Yeah, pretty cool. Okay. So let's start. I think the first uh, is to gather the data set, right? So in this grizzly bear model, we had started to first get the data set and save it. All right. So let's see. So okay. So there's a cool way to do it without any, search API keys, which are pretty hectic. I have gone through that. It's really, really bad. So this is the way of manually scraping Google Images, right? It's a great way. Hmm. So, okay. Basically, what you have to do is you have to search Google Images about all right, yeah, yeah. Basically, you have to search for the data set on Google. Let me show you how to do that. So, okay, between our four types of bikes, I think let's start with the first one, sport bikes. Cool. Let's go to google.com. Let's search sport bike. Let's go to images. Okay, so this is a cool part. What you have to do is scroll down to the bottom. I know not every bike uh, will be the correct one, but hopefully we can clean this up later. Yeah. So once you have scrolled down, just go to the console and you have to use this command. Basically, what it does is it scrolls the website, the Google image page, and gets the URL of each of the images and neatly list it in a CSV. After entering, we should see a CSV downloaded. Not sure why it didn't happen. Okay. Mm, let's try it one more time. I tested it yesterday, so it should work. Hmm, for some reason, I'm not able to download this. Let's see. Okay, yeah. So it says disable your ad block. Sorry, I forgot that. Let's refresh it without the ad block. Let's try to run it. Yes. So we have a CSV. Great. CSV reader. Let's check the CSV that we have downloaded. Okay. Let's see. Have we got the URLs or not? Yes, we have got the URLs, but it's not the correct ones. You see, only 25 images have been downloaded. So we'll try once again. The trick is to disable your app block and scroll to the bottom until you have 100 200 images or so. Now you have that images loaded in your browser. Now just run the script again. Now let's test. Okay, this is our new CSV file. Let's see. Yeah, now we are talking. Now we have 100 images of sport bikes neatly organized in a CSV. This is what we want. Let's just, you know, rename it. Let's just say URL sport. Keep it here. Now let's go to our other class of bikes, that is dirt bikes, right? Let's gather some dirt bike data, shall we? Okay, so dirt bike looks cool. Scroll to the bottom. Uh, Coffee is so good. Okay, now we have loaded the dirt bikes, the command. Now we have the CSV. Let's test it again. So why I'm testing it again and again is one of the primary things that I feel a good deep learner should do is have a knowledge on how to gather data. You know, that is one of the primary skills that you need. So yeah, this is correct. Let's just rename it again to say dot. Cool. Let's go on to our third class of bikes. That's gonna be scooter. Okay, scooter. Scooter bike should be a good term. Let's see. Yeah, scooter bikes. Yeah, this is giving us some appropriate images. I know there are some bad images, but we will take care of it later. Cool. Run the code, download the CSV, sorry. Yeah, let's test this. Test, additional checks. Correct, this is right. Let's rename this again. This is gonna be URLs scooter. Now let's proceed on to the last one, which is cruiser. Cool. Okay, by the way, I'm being inspired by this guy right here, George Hotz. He's a great guy. He claims to be the android of self-driving if Tesla is the AI. So these guys at Comma AI are solving uh, the self-driving problem through open source code. So I'm really very motivated by him when making videos. So I highly appreciate that you go and check this guy out. Cool. Okay, so let's go and gather dataset around cruiser bike. I think I misspelled it. Okay, try it one more time. Cruiser bike. Okay, I think cruiser bikes gives a bad result. Okay, cruiser motorcycle will give you a better result. Cool. You have to be very of the search term that you are using. You need to know that will that give you the correct data set or not. Okay, so we've got the correct data set, I believe. With the CSV, check the last time whether we have got the correct CSV. Yes, we have around 100 images of cruiser bikes. Okay, let's rename this finally to URLs cruiser. Okay, so now we have 4 CSVs. Okay, so how we're gonna do this is, firstly we have to upload this, right? We have to upload this. Uh, let's file one more Jupyter tab. Okay, so this is the data. So we had built a bare data. So what we're gonna do is build a folder of these bikes, and let's see how we will do that. Basically, Okay, so it tells us choose an appropriate name for your labeled images. Okay, we have done that. Cool. Time for some code. Okay, so let's go. The first folder we want to support, which is corresponding to our first um, type of bikes, sport bikes, right? Let's call this URL sport, which we have named. Let's add a new cell. Uh, then what we are gonna do is we are gonna build a directory in which we are gonna store all the different types of bike images. Gonna name it bikes. Okay, let's make a directory of bikes. I think we have done it successfully. Let's check that out. Cool. We have got bikes, sports. It will be empty, I believe. It is empty. Okay. Want three more. Cool. Let's do it. Uh, the next type is dirt. We want this. Check it out. That is created. Great. Okay. The last two. The last one was scooter. Scooter. Let's make last one cruiser. Okay, cruiser, cruiser. So we should have all four folders. Fantastic. Now what we're going to do here is upload our CSVs so that we can use those CSVs to download images corresponding to all these folders. So let's click on upload. Let's say URL cruiser, dirt, and grizzly. Sorry. Sport, scooter, cruiser, and dirt. We're gonna upload these CSV files one by one. Okay, so now we have the CSV files in this directory called bikes. Great. Now what we are gonna do is let's do a path.ls. Let's see what new stuff is there. Okay, so path.ls. Okay, okay. So this is the path. Um, Great, yeah, we have all the four folders, we have all the four SVGs. Great. Now, what we are going to do is we have to start downloading the images. This is the fun part. Okay. All right. Hmm. So this is how you download the images. So yeah, I have to take, yeah. Let's download some images. So pretty cool thing about um, Jupyter notebooks and Fastai is like they give you built-in functions to do, almost everything that you need. That's pretty cool. So we're gonna use the download images method. Let's see. Okay, let's see the doc. Okay, cool. Let's use this download images. But first, let's see what dest has. Okay, so cruiser, cool. And what is the value of r/file? Great. Okay, so we have the correct paths and files. Now we're gonna download some images. I think we should have the images by now. Let's check. Cruisers. Oh, great. We have 178, 180 beautiful images of cruiser bikes. That's really fun. That was easy. Let's try and download other images. Okay, so let's download scooter. Okay, let's run this so that the folder and file variables are uploaded. You can run this as well. So it won't make a directory because it already exists, right? Let's verify the variables. So the destination should be scooter path, correct? And the path slash file should point to scooter CSV. Great. Let's download some scooter images. Let's check it out. Great. We have some scooter images, approx 180 of them. That's great. Now let's try dirt. Let's make a dirt directory. Let's check. Okay, that they are pointing to dirt.csv. Let's check the destination folder. It is dirt folder. Let's download some dirt bicycle images. Let's see. Great. We have some dirt bike images. Affirmative on that. Now let's do this last bit. Sport bike images. Let's check the destination. It's correct. Let's check the path slash file. It's correct. Let's download some sport bike images. It's done. Let's check some sport bikes. No, this is scooters. Sorry. Let's check. Okay. Let's. Great. Okay. Now we have all the data sets here beautifully listed into all these different folders. Perfect. Now we're going to use some Fastai tools and check. Okay, so first of all, what we have to do is we have to define classes, right? So add a cell, let's define some classes. So our classes were sport, dirt, scooter, and cruiser. Okay, so these are the four classes of bikes that we want our computers to identify, right? One more thing. So when you download images, you can also verify via built-in method that Fastai provides. Let's use that. Seeing classes, verify classes. Let's see. Delete. Mm, okay, let's open an image. What is a directory? It should be a directory. Let's check what our destination folder destination variable contains spot, right? Okay, let's forget this. We have verified that we have the images. Okay, cool. Okay, so now the interesting part. So, okay, if you would have been following the Fast AI course, it has done the image downloading via search images Bing method, which internally uses a Bing key, but that is really shitty. I have tried Bing and it's like really shitty. So the pain that I experienced, I didn't want anyone else to experience that. That's one of the secondary reasons that I'm making this video. Don't go with this. Download and prepare the dataset as I've showed you. Okay. All right. Now, what we are gonna do is now finally we're gonna load some data. Cool. So our path is bikes. Great. Now what? we have done here is we have used an inbuilt fast AI method called get image files. We have given the path and it gets all the images that are in the paths. Basically, all the images on those full folders. Four folders. Yeah. There's one more path to check if something has failed. Some images have failed or not. Let's try that. Zero. Great. No images have failed while downloading. If it would have, you can use this command to unlink that, right? Again, there's a lot of theory. We like practice, but these are really important theories. I would recommend you to read them, right? So let's create one more block. Let's define our bikes model. So basically, we want to first build our data block, right? Data block which contains the data regarding the data sets. So this is the data block. We want get image files, the function that we defined earlier to get all the image files. So 20% will be our validation set, other 80% will be the training set. Seed is just so that we always get the same validation and data set. You can read more on that in the chapter notebook. Cool. And we have to apply the transformation. We want every single images to be 128 size. Let's run this. Great. We have our bikes data block. Now you can read more on the function of each lines, right? Okay. Now the fun part starts. So data loaders. So now what we are gonna do is we're gonna create a data loader variable which basically is gonna load the data set. Okay. Now once you have the data loaders variable created, you can actually visualize your data. Let us do that using this command. Show me some bike images, please. Yeah, there you go. Now we have labeled bike images, mind you, because of the folder that we have put it into. We have a sport bike, a cruiser bike, sport bike, scooter. This is amazing. You know, it's not even 30 minutes and we have prepared the data set and we are visualizing it. Such a powerful tool. Cool. Okay. So another important part is how you load the data. So there are multiple ways to, crop the data. If you try, there are multiple resize methods available. So let's just visualize it one by one. So bikes, bikes.new squish. Then again, what you're gonna do is load this and then show. So what you're doing is you're using this squish resize method. So what it does is it puts the entire images into a specific size. I guess that's 128. So what it enables us is like here you can see the bike images is cropped. So our model will have a really hard time learning uh, from the image that this is a sport bike or not. So one of the techniques is we can use this resize method. So squish these images in uniform image size. But the problem is the image will stress. The image will stretch. So this also is basically, you know, kind of polluting our data. This resize method. Okay, so yeah, so this kind of pollutes our data set. You know, the images are being stretched, which is also not good. So another technique is pad mode zeros. So what you basically do is, um, so basically add padding to the images, right? So what that does is it makes it avoids these two problems. So first of all, your image won't be cropped centrally, so you'll get the entire image. And second problem is it won't be stretched, so your data set won't be deformed, right? So let's try that and visualize our data. Let's see, spikes. Great, yeah. You can see padding has been applied. Now the entire image is in focus and we are not stretching it, so we are not losing or polluting our data. Cool. Now one problem with this is that, okay, so yeah, the problem with this is what you're gonna do. So you have, empty pixels in your images. So basically, your computer has to go through these empty pixels, which is a waste of computation. So this is one disadvantage when you're using pad mode zeros. Anyway, let's move on and let's do a random resize crop. Okay, that way you see we are augmenting the data basically and generating four different images for one single image so that we have much more data set and the machine should basically able to recognize all these four images. Let's do that. Okay. Okay, so yeah, so let's do a random resize crop on our data sets. Uh, 1 second. Then let's visualize it. Okay, so you can see what happens here. So basically, out of this one image, what we have done is perform a random resize crop, and it has generated four different images by cropping. So you see, these are four potential data points for our model to learn, right? So that's really great. So let's move on. And another way of data augmentation. So data augmentation is really great. So what it does is you can see here using one images you can generate eight different images and the machine should be able to learn all this. So basically what you're doing is improving the quality of the data using data augmentation. So this is really cool. So let's try that. Bikes, bikes, bikes. Okay, let's augment. Let's see. This is the interesting part. Right. So, see, with one image, what you have done is basically augmented the data and it has twisted the data, it has turned the data in a different angle, and this is the magic of data augmentation. With just one data image, you are able to build all these different types of data which are different for a machine as and it just provides so much better data set and the machine will be able to generalize that this is a sport bike, right? So that's great. Okay, now the fun part starts. Yep. So what we're gonna do is, okay, so we are gonna do a random resize crop finally and load that into a data set. So let's begin. Let's see bikes. So what is done here is basically you want to apply a transform of random resize that we saw above. 224 pixels is standard. Min scale is zero point 0.5 and also we have to apply a batch transformation of argument transformation, right? That's great. Now after this we'll just load the data in DLS variable. That is done. Now, the fun part, we're gonna create a learning variable. So this learning variable is basically a CNN learner, a convolution neural network learner. Again, a class provided by Fastai. What you can do is pass the data to that, specify the type of network that you're going to use. So we're going to use ResNet 18. There are different type of ResNet 50, and different others that you can use. Okay, and the matrix is error rate, the matrix that we're going to judge how the model is performing. So fine tuned by 4. The epoch is basically 4. So the learner is going to go through the data set 4 times to learn. This is fantastic. Let's just run it. Yeah, the magic of machine learning starts here. We are training the BikeNet model. Okay, so first round of epoch losses 11.4%. That's bad. Okay, no, yeah, loss is 6%. Okay, that's decent. Now loss is 4%. No, sorry, that's 40%. That's bad. That's not that good, but let's see. Okay, so finally, the loss uh, rate is 0.12. So, okay, so if you compare it with the beer model, the loss is pretty less here. You can see valid loss is 0.03, which is around 3%. We have 41%. That's really bad. Anyway, let's build the confusion matrix. So confusion matrix is the actual data and what is being predicted by a model, and uh, what's the score on that. So let's build the confusion matrix for our learned data. So as you can see, let's translate this. So basically there were cruiser images, and 23 of the cruiser images were predicted correctly. One, the model predicted it as dirt, and two was sport. So basically our model predicted one dirt bike as a cruiser bike and two sport bike as well. But anyway, pretty much what you want to see is uh, the diagonals should be deep blue. So that is the prediction. Actual and predicted should be uh, the same, and you should have very few errors around this. So now, as I was talking, that we saw during data collection that there were certain data images that were not correct, and I told you guys that we're going to clean them later. So let's do exactly that. So confusion matrix, and again another built-in classification interpretation class, gives us a great tool to visualize how our model is doing by this confusion matrix. Cool. So what we're gonna do is firstly plot the top losses. Like where is our model really not doing well, right? Let's plot the top losses, 5 losses, one row. Let's see. Cool. Now see, you can see in this images there are multiple bikes, or our model is really having a hard time. Then this image, kind of blends with the background. This it is confusing between a dirt and a sport. This a dirt and a cruiser, and this is not that good of a image. So you see, we can use this method to plot the top losses, and you can see basically what part of your data is really not that good quality. It's basically low quality data that will crop up once you use this function. So this gives us a great chance to clean our data. Let's do that next. So how we're going to do that is, so again, a great image classifier cleaner, which is provided by Fastai. What it does is it shows you the cleaner, the data, sorry, uh, which we will clean now. So it takes in the learn variable, and what it's trying to do is create a cleaner variable. So until it executes that, let me give you a brief example. So what it will do is it will generate a GUI, graphical user interface, which you can use to, clean the data. So in this case, this is a bad data image where there are two bears, right, in an image. So you want to get rid of this data. So you can delete that. If image is wrongly classified, you can change the classification and make that sort of changes. So let me show you. Yeah, cool. Okay, so let's go over the cruiser data set, and let's remove all the bad. Okay, so yeah, we have found an anomaly in our data. So this doesn't look like a cruiser. This is a sport. Let's let's classify this. This is not a cruiser, this is a sport. This can be a cruiser. Okay, so we wanna get rid of this type of data where there are multiple categories in a single image. So we're gonna choose delete. Cruiser looks good. Okay, we can also get rid of this data. Let's do that. Cool. No, we don't want to do. Now, after doing the changes from the GUI, what we're gonna do is, so the GUI doesn't actually makes the changes. We have to run some code. So first of all, uh, so basically what there are two type of operations that we have selected here. First is changing the classification, and second is deleting. So we don't want these type of images. So basically what you have to do is run this for loop. What it does is it deletes the category which we have chosen to delete. Let's call this delete delete um, bad data. Okay, okay, great. And we have done it. Another thing we want is move images from a different category. So we saw a sport bike here. We want to move it to the sports category, right? So this is moving, reclassifying. Reclassifying is a good word. Classifying. I don't know if it's correctly spelled. Anyway, we have reclassified. Hmm. So the problem is that the thing. So maybe this was the name of this image was 100.jpg. Now when we are gonna move it to sports, we're gonna see 100.jpg already exists. So how are we gonna? Let's look at what shootle.move does, right? So one great way is to check about a method is do this. It will bring out move source destination copy function. Copy function is callable copy tree. Okay. Now what we're gonna do is change the destination a bit. So let's say we are gonna use moved. Let's run this. Invalid syntax. Okay. Dot join. Okay. So what we are going to do is we will change the path for the images that we are going to use. New path equals to path dot get how can edit path. Let's check it out. Python edit path. Okay, so mm, let's see. So basically, what we want is, if it's not clear to you guys, so basically, the path uh, slash cat gives us sports directory slash 100.jpg. So the problem is there's already an image called 100.jpg existing, right? Sorry. So what we are trying to do is change this 100.jpg to say uh, something. Okay, so this is a for loop, so we have to change the path every time. Okay, let's see what path.cat is actually. Path.cat is right. Okay. Okay. Okay, cleaner dot change. Let's just print. Let's just print cat print idx print cat print ids. This is id and this is the category, I suppose. Let's run this. Invalid syntax. I don't know how to use print. Okay. ID4 category sport category sports. Okay. So basically, these are the two image IDs that needs to be categorized to sport from cruiser. Great. All right. Let's how to do it. So a good problem to solve, guys. Hmm. So basically, this is what they are doing, right? Shuttle.move cleaner functions dx cleaner f function. What does this do? Let's check the doc on this. Cleaner is basically image classifier cleaner dot fns. Hmm, cleaner behaves like a list of items but also index list of masks. Hmm. Okay, so this is the fun part, fixing a problem. Okay, we can really try out a manual stuff for this. Okay, so what I'm gonna do is really bad programming, but for the sake of time, let's do this. So basically, what is so 100.jpg already exists, right? So let's just change the file name. Let's not do it programmatically for now. So let's select this. So there's already a file 100.jpg. Let's try to rename it to 300. Cool. Let's run this again. Now, okay, one is done. Another one is 128. Cool. Let's search for 128. So this is the kind of hack that you have to do if you're not able to come up with solution. But again, whatever fixes the problem. Okay, so let's run this. 100, I think that is done. So 100, the new 100 here will be the file that we moved, right? Let's check this out once. This should be the red bike. Yes, yes, this is the red bike. Okay, so we have cleaned the data for cruiser. That is great. Run the cleaner again. Whoa, what's the problem? Can we go back, please? No, we can't. Anyway, let's try to train our neural net once again. Now that we have. Okay, so I think we have changed the files, so that's why it's not able to get this. Okay, so what we have to do is basically start over from the data block, I believe. Let's try it. Okay, show me some bike images. Computer, great. Let's perform some data augmentation again. Nice. So yeah, what has happened was since we moved some files, uh, the data block variable that we had created corresponding to the data set was now incorrect because the data has changed. So we have to, uh, recreate the variable. Wow, look at this data documentation, man. This is pretty cool, right? Let's do a random resize finally before we train our model. Okay, let's run our model. Let's train our model. This time it should work. Come on. And we should see a better error rate because we have trained the model once. We have identified the problems in our data set. We have removed the problem and we are trying to retrain our model. Let's see. Let's see. Give me some better error rates. Wow, already I think we are seeing some better error rates or not. 14%. That's decent. Let's check the confusion matrix. Hmm. I think a model has not improved that much. It is classifying five of the sports bike as cruiser, which is not really good. Not the top losses. But again, this is the part, right, where you are telling, cleaning up the data, retraining the model. This is the part. Okay. So, okay, yeah, you can see that this image is not really clear. This image is like, wow, we shouldn't have this image. You have a scooter, a sports bike, a dirt bike, and a sports bike. This is a really bad data image. This is not really clear. And okay, so yeah, so basically I just want to take a time to appreciate like how easy it is to find top losses and remove that. It's this is the major problem you see. So anyway, let's fire up our cleaner again. And okay, so let's see cruiser. Do you want to remove something? We can delete this. We can. Okay, cruiser. Let's check dirt. So what we're gonna do is let's remove this. Uh, Multiple images are not cool. This is not cool. Mm, this is not a dirt bicycle. Sorry, a dirt motorcycle. Dirt bike. Hmm. Okay. Let's go on to scooter. Let's see. We have a low quality data set there. This is not a scooter. This is not a scooter. This is a sports bike. This is a data set. This is a sport bike. This is a scooter. But okay, let's keep this. This is a sport bike. This is a sport bike. Wow, there's a lot of low quality data here. That's the bias, right? You search on Google, but you don't get the correct images. Some of the images are not high quality. You want to remove these. Okay, okay, let's remove this. Let's remove this. This is a sport bike. This is a sports bike. Finally, let's check. Is there any low quality data regarding sport bikes? Wow, this is bad. This is a dirt bike. This is bicycle. This is a dirt bike. This is a dirt bike. This is a cruiser. You can see there are a lot of these are not really sport bikes, but let's keep it in this category. Okay, we want to remove this generic data. This is a generic data. We want to remove this. This is a keyring, but it's a sports keyring, so we'll keep it for now. Okay, this is kind of a cruiser to me. Okay, so let's after making the changes in the UI, let's delete all the data. Then reclassify the images. So we were using this for test purpose. Let's delete this block. Okay, let's delete this block. Okay, again we're gonna be stuck at something. Dirt 71 already exists. So what we're gonna do is let's rename dirt 71 to something. Uh, 371. Let's go to 371. Rename it. I know this is not the best way to do it, but let's just do it. 122 dot already exists. 122. Rename it to 332. Okay. 71 dot already exists. Okay, so this is repeating again in dirt. So I think we have changed it. Hmm. So I think okay. So category equals to. So I think we have done cleaning the dirt. dataset. Let's only clean the sport one. Will this work? No. Okay. In cleaner dot change. Okay. Okay. So I think so. This is our manual category. We want to focus at not everything. No, it's not working. For IDs, let's try this. Function path is the path and manual category. Dirt. Okay. Okay. I'm not sure what has happened here, but okay. So anyway, we cleaned the cruiser dataset before. Now we have cleaned the dataset. Let's quickly load the data book again, and let's try to. So let's quickly try to load the data block again, and let's train our data again. So just to recap, what we have done is we have trained the model. First time we saw that the loss rate was high, which means our model wasn't performing well. The reason was that our data was not high quality. There was bad data in our dataset. So we have tried to clean two of the dataset, that is cruiser and dirt as of now. Okay, cool. Let's do some resizing again and again. Scooter cruiser sports. Oh, this is really good. Yeah. So let's do the final augmentation. This takes time. This is what I find pretty cool. Again, let's load the dataset with a final random resize crop and the augmentation transform. Right? We have loaded that. Now let's turn a model. It was I think 0.12 loss error rate, I believe. Let's see how it does this time since we have cleaned the dirt. Let me just data set. Come on, let's go less than 0.12. Come on. Wow, we have reached 0.10. That's 10%. Okay, so let's see the final error rate. Okay, so we had reached a lesser error rate here, but seems like in the fourth cycle we have again gone to 1.12. Anyway, confusion matrix doesn't look that good. Plot the top losses. Cruiser sport. This is a sport. This is a cruiser. Okay, so these are bad data. Let's try to remove uh, bad data from sport and scooter, right? Let's load the cleaner. I love this image classifier cleaner. It's really, really great. Okay, so let's just do a sports cleanup for now. Okay, so this is dirt. This is a cruiser. Lot low quality data in sports. This is a sport. This is a sport. We don't want this. This is a cruiser to my eyes. This is a cruiser to my eyes. This is a cruiser. Lot of bad data set here. I don't know. Okay. Fuck. Sorry. We don't want the image of a tire. Let's delete this. So after selecting the changes in the sport data set, let's delete the bad data that is deleted. Let's reclassify again. Okay, not this. Let's change the code a bit. Okay, let's go with the original code and reclassify. 51 cruiser already exists. So what we'll do is change the 51 cruiser into something else, right? Its name is 351. Great. Let's rerun this. 122 dirt already exists. Okay, so what we is happening basically is we are moving dirt image, which was in the sports folder, to the dirt folder. So, but there's already a 122 dirt image. So we're just gonna rename it and try it once again. 322 already exist. Have we done it? Let's try to rename it 422 then. 422. Okay. Rerun this 122 sports. Uh, okay. No such file or directory sport 122. Sports 122. Really? Yeah, we don't have that. Okay. Okay. Anyway, we can clean more, but this is fine for now. Let's just quickly test again. Scooter, cruiser, scooter, sport. Oh, this is a bad image, right? We will classify the scooter images finally last now. So again, just a word of caution, since I don't want to dedicate too much time on cleaning. So I'm just skipping on whatever files we can't move. We are obviously deleting all the bad files, right? So that's good. Let's check the matrix. So 0.12 was the last error rate. Let's see if we can get an improvement. Okay, let it run. Hmm. So I believe, sorry. Okay, so the error rate has actually increased. How sad. Confusion matrix has improved a bit, but not improved in other areas. Anyway, uh, let's plot the top losses. Okay, so this is a bad image right there. Let's try to clean the image one last time, right? Let's try to clean the scooter image set. Scooter, how well it is doing is actually, yeah, it is predicting one sport bike as a scooter and three dirt bike as a scooter. So let's possibly remove this so that all the 36 images should actually be predicted as scooters. So this is what we want. Let's go to scooter and let's go to scooter. Okay, so this is clearly not a scooter. This is a sport bike. This is a sport bike. This you can say is a bad data set. You have two different classes of one image. This is a sport bike. This is a bad image. This is a bad image. This is a bad image. This is again a bad image. This is a sports bike. This is a bad image. This is a bad image. So you'll actually, this looks to me as a dirt bike. This is a bad data set. Let's delete it. And this is a great data set. This is a bad data set. Okay, this is a bad data set. Okay, let's delete all the bad data. Let's try to reclassify the data. 100 bike sports 100 already exists. What we are gonna do? 100. This is sports. Let's go to 100. Just rename it to 300. I know there will be a better way to do this, but what can we do? 400. So that was replaced. 122 already exists. In sport, 122 already exists. 122. Let's try to rename this to 422. Let's try to run the reclassifier again. Scooter 122. No such file or directory. Okay. So cleaner dot change. Actually, there should be a solution to this. Cleaner dot change fast AI. No file already exists. Let's look at the forums, how people are dealing with this problem. So that's one of the great parts. Okay. So I don't know. Mm, anyway, let's move on. Let's move on. I'll try to figure out a solution later. Anyway, we have gotten rid of many files which we deleted, so that's a good start. Reclassifying uh, wrongly classified images is what we should work on, right? Anyway, cruiser, scooter, scooter, cruiser, this is great. Let's do this stuff again. Let's finally load into our data loaders and let's run it. Let's check the error rate one final time. Okay, it starts with a 20% error rate, goes to 15% in the next cycle, goes to 14%. Okay, it remains on 14%. So this is not the best, but anyways, in around 1 hour we have anyway built a model which is 14% not good, but still it's decent, I would say. Okay, let's skip all this and now let's check our model, right? We can actually export the model. Okay, so now we have our model. So learn that export. So basically it will export your learn variable which shows your model. I think we have done that, right? So how to check if we have exported successfully is just check pkl files. This is the extension that your model is exported into. So export.pkn. Okay, we already have the model. Okay, so what we're now gonna do is load our model and just use it to predict. Okay. Okay. We are gonna load our model to learn inf variable, right? And we are gonna use it to predict an image. And this time we'll take a fresh image, right? Which is not the part of our validation or training set. Cool, that is the actual test. So before that, let's try to search for a specific dirt bike, right? Or what should we do? Let's test. Okay, so KTM Duke 390. This is a sports bike. Let's test if okay. So I believe this was not a part of our data set, right? Let's download this image as KTM. Okay. Now what we're gonna do is, so what I like is in this bikes directory, what I like to do is create a new folder, which is a test folder. So all the new testing data, you can actually keep it here. So untitled folder, not sure how you can. Okay, so test. Okay, test. Let's upload. Okay, so this doesn't work. Great. Anyway, let's upload this KTM in this test folder. Cool. Now, since we have taught our model how to classify, let's classify data slash bikes slash test slash KTM. Sport! Great! So it has classified our KTM image as a sports. So yeah, our model, our machine finally knows the distinction. Let's just try once more for a good measure. So let's try a scooter. Okay, scooter, but we want a different image which wasn't already in our dataset. Let's take a random scooter image. Okay, this will work. Scooter test. Cool. Let's put this in the test folder. Scooter. Sorry. Okay. Come on. Let's try to identify what this is. Scooter dot test. Yes, our machine is able to identify this as a scooter. So that is great. We now have a model, an exportable model that we can use anywhere in a mobile app or a web app or anywhere, which can be used to classify four different types of bikes, and it's been almost less than 1.5 hours, and we have built a image classifier model which has a decent accuracy, if you ask me. And we haven't written that much code, but still we are able to predict some with some good probability. Our prediction is good, so that's great. There's also in this chapter, the ways to deploy your app. You can actually make a GUI which you can use to upload images and those sort of things. I'm just gonna avoid it for now because anyway, our I think title or goal of the video was, to make our machine learn different type of bikes, and we have done that. So yeah, I think we have successfully created BikeNet, which can classify 4 different types of bikes. We can also, clean our data sets a bit more and improve the accuracy. But this is a pretty decent model that we have created in under 1.5 hours from scratch. That's great. So I'm gonna end this video on this bit, and we should. I'll create one more videos as I go along the chapters in Fastai course. I find it very fascinating, and I'll make I'll present a video for you guys. So make sure you go through this chapter and course. It's a really great course on deep learning. Okay, that's it, guys. If you like this, if you liked my effort, uh, do show that in form of comments or likes if you want to. Otherwise, you are free not to. But that's it from my side today. Take care. Bye.